Hello and welcome to this next tutorial in our journey to learn programming with Julia. And in the last video we looked into how to organize our code into functions, how to call functions, how to improve the readability of our code by putting it into functions, even some commenting of these functions and giving documentation for these functions. And we'll continue where we left off. I think we mentioned here that the active player, the second player, doesn't really use a strategy here. So let's first think about how can we try to organize our code a little bit better. Because obviously at the moment, if we scroll down, we have 180 lines of code, and that's actually a large file. If you want to read the file and try to understand what's going on, you have to read quite a lot of lines to understand what we've been doing. And for that case, it makes sense to sometimes split what we're doing into several files. And for this, I would create a new file, and I would save this file as model.jl, and this is where our model will reside. And we can put stuff in there like we want maybe our car, so the actual description of the data, the loading of the data, maybe even the splitting of the cards. That is all preparatory stuff, and we can cut this out and put it into a model. And now obviously if I run our main.jl, it will not work because it's missing functions, it's missing data types, and for this we need to load our model.jl. And since we took it from here, we can basically call source include. So the function that we were looking for was include, and if I do include, then I get everything that's in the deal cards, everything that's in the model.jl. The last function is the one that we get a response for. And if I now execute everything, dex is not defined. And you might wonder, why is dex not defined? Didn't we set up dex? Yes, we did, but it was in memory, and dex was not available to run games. So even, let's test something. I'll close the Julia console, open up a new console. If you're wondering how I'm doing this, using key combinations, if you press Command-Shift-P or Control-Shift-P on a Windows machine and type in Julia, I get all Julia commands and their hotkey versions. And the hotkey for starting a REPL is Option key. Windows users might not recognize this, but you will see a different key here, J, and then Option key O, and this will give me Julia REPL. And I can also have JK is here, stop the REPL. And this is what I do. I just do JK to close the REPL and JO to open a new REPL. And if I now execute the code line by line, this all works fine. The include works fine. I have the RNG, I do the run game, I define my players' names, and I do load deck, that thing works, I do wins, and I call this, and here the run game function, which basically uses player goes first. Since we've moved this into a function, the dex variable, this variable, is no longer accessible. So if we have a look in this, this will have a look at dex, and dex is here in the global context, down here. It's a variable in this loop, which is the higher context for this method. So we should probably give the run game the dex that we're using. So the dex player who goes first, we should probably, the first thing to do is we need dex. And the dex variable, it's not, we cannot provide a default for that. It's something that is necessary. So we can put dex in here. This should work now. If I rerun the function and provide the new method, and if I'm not mistaken, yeah, it works, and I get my result. About 80% of the time the second player wins. The question would now be, what is, in this case, dex is of the any type, because we didn't provide a type clue, and we should give it a type. So to make sure we don't put in something in there on accident. And for that, I think it makes sense to have a look at where did we define DEX. So DEX is the return of deal cards, and deal cards is defined now in model.jl. And I think if we press the F2 key, no, F2 key is renaming. Can I go? Yeah, F12 key. It's so if I right click it and go to definition, it will take me to the Julia code where this function was defined, even if it's in a different file, because it knows where it's coming from. And we know DEX is a vector of car, and we will take this into our definition here for run game. So if I run this now from the beginning, it works, and I can, even if I kill the REPL and do everything again, it should now work. Activating the project. And yeah, at the end, we have 178 wins for player 1 and 822 for player 2. So what would we do now? So maybe we have names for the players, and actually the wins player 1 and wins player 2, we don't need this anymore because it's in this wins variable, and the game has ended variable that we defined in the very beginning. We've never actually used it, so we can remove that because the game is run here using a while loop, and the while loop determines when the game ends. And if you're wondering what these little triangles here means, is I'm using git in the background, and this is where I've deleted lines in comparison to the next one. This is where I've changed a line, and if I add a line like this, then this will highlight in green. So this is where you see the changes to the last commit if you're familiar with Git. If you're not, I will link you to a tutorial where you can get an understanding of what Git and GitHub does, because it's very useful if you want to work on a project with multiple people. So what we should do here is we should actually print the outcome of this result. So we'll just do print line, and we say player, and then we have the name of the first variable. Oh wait, that's a dollar and parentheses, name player 1, and we do this again. How many times he won? Wins 1 times. And let's see, player 2, name player 2. So now we should have Alice won 178 times and player Bob won 822 times. So apparently at this moment, a very good strategy is to let the other person just go, because top speed is only a good criterion in 1/5 of the cases, and player 2 will actually, by giving control back to player 1, play better, because that player will make more mistakes. Okay, so we wanted to finish the second player, who will do random play, and at this moment it's kind of, so if active player 1, we just do the comparison by cards directly, and we push the cards on the table, and where do we actually do the evaluation? If the top speed, oh no, actually we take the cards and put it into the deck again. Sorry. So let's have a look at how the second player will do this. So active player will only change if that player loses. So second player plays randomly. So let's pick a random attribute, and for that we will do the rand function, and we will use the RNG to ensure that it's reproducible, and we want to take a number from 1 to 6 maybe. So if I do this, I get a number from 1. How many attributes does our car have? We can have a look at the car. It has 1, 2, 3, 4, 5, 6 attributes. and that is whatever that player will pick. So let's call it car property index. Often if you write an index, you just write IDX. As if you come across IDX, it's an index. And that is the index of the attribute that this player will pick. And now we have, let's see, cards on table 1. This is what the first player will do. And we will access, so let's put a card on the table first. So let's see where we are. So if I execute this now, this will be empty because cards on table is not defined. It's only defined inside of this run function. So in order to make this work, we have to get something into the table, and we could do this by doing this. But then we see cards on table. Wait, it hasn't been defined, so we cannot push into it. If we do this, it should work. And then it says dex is not defined because we haven't loaded dex. Because it happens in a loop, and if it happens in a loop, it does no longer exist outside of the loop. And this is one layer in, so when we're debugging directly into the REPL, we're in the main loop, so we're on the most outside loop, and we do not have access to this dex variable, unless I just execute this highlighted code, which by highlighting it, I put it on the highest level of execution. So dex should now be available if I do this push function here. So that pushes the Toyota and that pushes the BMW onto the deck. And now let's see the cards on table. The first car is the Toyota, and now I'm wondering, I want to access the car property IDX, and that's the first, so that he picked the top speed again. And let's see, do we get access to the property by doing this? We do not. Let's see how we can actually get access to the property names. So what would we look for? We look for Julia, we look for access struct property by index. Let's see if best way to access field in area of structs. Collections and data structures, struct types. So sometimes what this is called, in at least as I remember in Java, it was called inspection. So if we don't know what the variable names are, let's see if there's something like Julia inspection, reflection, or reflection, sorry, reflection. So I have a struct and I can get the field names, and that returns a tuple of the field names, okay? So what we do is we do field names of this car. Let's see what this is. There is no method matching field names. Why not? Because it's probably from a package. Is it? Provides a variety of runtime reflection. Field names. Where does it come from? Field names is from base. So field names should exist. There is no method matching field names car. Let's test this if this works. Okay, it works for a rational, and I'm wondering, maybe it only works for car. Okay, yeah. So field names is not something that I execute on an object or on an actual car, but on the data type of car. So if I type in field names, I get a tuple with the individual symbols that I can use and which I could then access. Let's see if I can access this by doing maybe .name. Does this give me something? No, it doesn't. How would I access the name of this? Julia access field by symbol, by a string argument. So this is how it doesn't work. That's also a good tip. If you're looking at Stack Overflow, the first thing is always the question. You should look up for where someone mentioned what is the actual answer to it. Do something as symbol of the name, get property. You can access field with symbols, so you can convert the string to a symbol and use get property. Okay, let's see if that works. So this returns the symbol. And what is an S? It's the cylinder. Actually, we already get the symbol from this. So this is the symbol. And what do we do with that? Get property. Get property of the car that we have for the symbol S, which we didn't define. We should define it here. So we put in the cylinders, and let's see what that is. 6. Does that car have 6 cylinders? Let's hope so. It does. Cylinders was the last field. So that's how we get to the actual properties. And now we want to see who wins again. So what do? We get the field names. We get, let's say this is value 1 because it's from the first player. And we get the value 2 by calling the same symbol but on the second player's car. So we pick a random item, we pick the field names from the car data type that we've used, and if we do all of this, we can now see we don't know 360 what that actually is. We could print it out as a debug message. Print line the item or the property $S was picked. And now we just, if we do the same thing as above, if cards on, no, not cards on table, if value 1 greater value, actually we do it the other way around, if, because it's player 2 that's playing, is larger than value 1, then player 2 wins, and we will just write this, and the active player does not need to change because it's already player 2. Let's put this, if this is the case, then we do this, value 1, is, so this is how it should look like. And we do an else. Otherwise, we copy all of this and we push the cards into deck 1, say that player 1 won, and we put the active player back to player 1. So for now, kill the REPL to see if everything works. Press on play. Okay, we now see that player Bob, so the second player, now only wins about 70% of the time. Let's do it again, 70%. Oh yeah, it's really because it's reproducible. It will always be the same because we, at the beginning, we give this Xoshiro a 1. If we don't initialize it, then it will be different every time. It will be quite similar because obviously the randomness does not have that much of a big impact. And now player 2 wins about 70% of the time, maybe a little bit less. Maybe 67% of the time. And we now have a final simulation of this game. A player that always picks top speed against a player who picks a random item. And what is kind of inconvenient is the strategy, how it's played here, because if you want to write a new strategy, you would have to replace all of this. And this is not really how you would try to do this. You would obviously try to let the player pick a strategy function, and the strategy will just do something and return whether they were successful or not. And we could move this out of the way, and I think this is the point where where I at least realize that developing a simulation of two agents without a proper infrastructure is not the easiest of things. We've come very far. We've used a lot of the features and functions of. Let's move this away because this is in here. So we only play 100 rounds, and if player one always wins even if it's a draw. So we should. That's interesting. So if Dex, we could at least return a 0 if both players still have cards. If length, actually we will just put this here in the rounds played, and we'll just do a debug and print line. There was a draw, just to see if this ever happens. No. So in this case, even if we do not control no draws happen. Oh, because we put debug to false, right? So let's not debug this. Let's say we print this anyways. Let's see if there's draws. No, there were draws. So in some cases there might be draws, and in this case Alice gets attributed this as a win. Does she run game? No, it actually doesn't return anything, so that might be interesting. In this case, let's have a look at the wins variable. It's still a 2-element vector. It doesn't count it. What's the sum of these? In the last version, 316, 684. Actually, that's 1,000. So it seems to be attributed to player one. Okay, I'm sorry. I'm getting. I'm digressing, and the purpose of this video is to show you how to finish the game, how to actually access the variables by variable's name or by the symbol. And here we get to a point where everything gets a little bit complicated, and we would like to exchange the strategies of the players, and we would probably develop more strategies. And one thing that you didn't notice is that you kind of created an agent-based simulation. You have two agents, one agent called Alice, one agent called Bob, and they use different strategies in playing this card game. Not the best strategies, one would say. You could have a strategy where a player would learn from what they've seen and try to improve, to pick the different symbol for the different card that they have. And over time they would get better, and you would see how fast would one player improve over time. We would like to visualize the data over time, and this is where a framework comes in handy. And this is what you will see in the next bigger section of the tutorials. We have a tutorial on the library AgentsJL. We have a library developed not by us, but by a group of very competent Julia developers. I think I forgot the lead author's name. I think he worked at Max Planck in Göttingen, and yeah, this is the library called AgentsJL, and it takes a lot of the work off our shoulders. And now, as you have all your basic stuff ready and you know how to program a basic simple program here in 2 files, even reading some data and writing some data, you are now ready that we get started using AgentsJL, which we will do in the next video.